On the surface, it looks like artificial intelligence is growing exponentially more powerful every single day. We look at the frontier models like OpenAI's Oven or upcoming milestones like GPT-5 and assume the path to super intelligence is clear. But behind closed doors, elite software engineers and venture backed startup founders are hitting a brutal, invisible war. And here is the shocking truth, it is not a computing problem. The AI industry is quietly suffering from a massive, systematic hardware crisis known as the memory wall. You see, we have successfully engineered a Ferrari engine capable of running billions of mathematical calculations per second, but we hooked it up to a microscopic bicycle fuel line. Nvidia has become a multi-trillion-dollar giant because it makes the fastest calculators on earth. But calculating fast doesn't matter if your machine takes forever to remember what it was doing. Because of this single bottleneck, running AI applications is becoming unsustainably expensive, incredibly slow, and catastrophically forgetful. Welcome to the memory wall, the hidden crisis that could bankrupt the AI race. So, to understand why memory is breaking the AI industry, we have to look inside the physical silicon itself. In traditional computer architecture, data storage and data calculations are physically separated. This design or the layout is known as the von Neumann bottleneck. When a modern GPU wants to perform a calculation, it has to fetch data from the memory blocks like RAM or HBM, that is high bandwidth memory. Moving data across that tiny physical gap consumes up to 100 times more energy than the actual calculation itself. Processors are spending most of their time completely idle, starving for data. In the world of large language models, this triggers a massive engineering nightmare called the KV cache problem. When you chat with an AI, it cannot simply generate the next word out of the thin air. To maintain context, it has to actively look back and reread every single word previously spoken in that entire chat session. Now, imagine an executive with a lightning fast brain. They can analyze data at a superhuman speeds. However, their working desk is the size of a tiny sticky note. They can only hold a few words on it at a time. Every single time they need a piece of past information to write the next sentence, an assistant has to sprint all the way across the office to a distant filing cabinet to fetch a single sheet of paper. This sticky note disk is the GPU's ultra premium video RAM or RAM. As your conversation with an AI grows longer, the sticky notes piles up completely. When a RAM hits its rigid physical limit, the system is forced to throw older parts of your conversation history into the trash. To make room for new text, if you suddenly ask a follow up question about something mentioned at the every beginning of the chat, the AI cannot answer. It is forced to pay what engineers called the recompute tax. The system must waste a massive amount of electricity rereading, processing, and recalculating the entire chart history from scratch. This single flaw blows up data center electricity bills and introduces heavy latency to your applications. This bottleneck is actively squeezing corporate cash flows and destroying the unit economics of early stage AI startups. So, to combat slow transfer speed, chip manufacturers rely on high bandwidth memory or HBM, which stacks memory layer vertically right next to the processing core. But manufacturing HBM is an incredibly complex, low yield process. This has created a severe global shortage, driving memory prices through the roof and crushing the profit margins of companies deploying large models. This crisis has also created what is known as the edge AI ceiling. So, the reason we do not have fully autonomous, hyper intelligent AI agents running locally on a smartphones, smart home devices, or medical drones is simple. The model's active memory state cannot physically fit inside the small memory chips of local consumer hardware. This leaves early stage software startups trapped in a brutal dilemma. If they want their AI agents to remember user preferences and complex multi step instructions, they must pay astronomical cloud computing bills. To keep massive context windows open, even if they try to cut cost, their agents suffer more severe AI amnesia, forgetting the user's core command mid task and rendering the product useless. So, how exactly is the market trying to fix this multi billion dollar problem? The industry is currently split into two distinct competitive waves. The first wave is hardware centric. Next generation silicon startups are trying to design processing in memory chips, placing mathematical logic gates directly inside the memory cells themselves to completely erase the physical data transfer distance. But building new hardware factories take years and billions of dollars. To solve this crisis today, a second wave has emerged, that is software defined memories. High profile venture backed startups like Memo and Super Memory have entered the arena with a brilliant software layer instead of crowding the AI's expensive tiny kitchen counter with an endless stream of chat history. These tools act as an external digital brain. So, so just imagine when you interact with an AI, these frameworks automatically extract key facts from the conversation, compress them, and store them away in an external vector database. And when the AI needs context later, the tool surgically injects only that specific fact back into the active prompt. This keeps the model's active context window clean, fast, and incredibly cheap to run. It looked like a perfect victory for the software ecosystem. The memory bottleneck seems completely solved, right? Wrong. Actually, because this entire software architecture suffers from one fatal underlying vulnerability that the industry is completely ignoring, and that is blind trust. Tools like Memo and Super Memory act as a passive filling cabinets. They operate on the absolute assumption that whatever the AI output is 100% correct. If the AI model hallucinates a false fact or creates an innocent assumption during a chat session, the memory layer will blindly capture that error, permanently write it into the vector database, and forever poison the AI's long term memory. Once a hallucination is written to a memory, every future decision that AI agent makes is fundamentally broken. Currently, memory frameworks are passive storage bins. They lack the critical runtime intelligence to filter out noise, validate facts, and self correct before saving data. And that is where the software defined memory layer completely breaks down.